or I can hear. Share. So on the homework, and some people have already submitted it. My last class asked if they could resubmit, which is fine. But it won't let you resubmit right now. For some reason, I left it at 1 and forgot to change it. But I will change it right after class if you need to resubmit. Okay, so the first set of data, Bella went on a walk outside and saw some snails, fox, deer, and ducks. And she made a chart. This would be a bar graph. Of her data. And we said right before we realized I couldn't hear anyone that the data was qualitative because it is non-numerical, which makes it qualitative. How many fox did she see? Anyone?
5.
We'd go to the fox and we'd count up and it goes up to 5. So she saw 5 of them. What's the mode? Mode is most often, so you'd want to know which animal she found the most. And that would be the deer.
Oh.
Because she saw 9 of them. So you want to be careful. A lot of times students want to put 9 for the mode. 9 is how many she saw, but what she saw the most was the deer.
Oh, I was confused on that one. I thought it was like how many numbers were like repeating, and I'm looking at the graph and I'm all repeating.
Yep. And that's true because usually we see mode with numbers, but you can find the mode with qualitative data. We could not find mean and median and range, but we could find mode. So it just means which one which she saw the most, and she saw the most deer. Of the 4 different animals, how many did she see in total?
I got 22.
I think that's right. You would add these up. So 5 and 5 is 10, 13, and 9 is 22. Any questions on that? Any questions on the bar graph? Yeah, this one I used to put how many different animals did she see, meaning that I wanted the 22, but then I'd get 4 because it was 4 different animals. I still don't like the way I have this question written, but okay, for the next one, it was miles per gallon, the efficiency of a car from 215 model year vehicles. How many vehicles were in the sample?
I got 463.
For the number of vehicles?
Let
me look. And the number, okay, so each one of these
I
dots.
get 16.
Yeah, each one of these dots is a vehicle.
Yeah, that's what I got.
Yeah, it's kind of, you could use it like a box plot.
I thought it was like, I was counting like the repeating dots too.
Oh,
so yeah.
I see. Yep. So each dot was a vehicle. So you'd count them 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16.
Okay.
How many miles per gallon was the mode?
31.
The miles per gallon that we saw the most of was this one in the middle. This is 30, 32, so this was 31. There was 6 of them. So the 31 miles per gallon was the most. Any questions on that? Would this data be qualitative or quantitative?
Quantitative.
Because it's a number, it's quantitative. On a test, I would give this graph, any of these graphs, and say write a paragraph about them. And then sometimes I might say include something, like I might say write a paragraph about this, including the mode. And that way you're telling me more stuff, but if there's a certain one I want, it's also in there. Okay, this one's a histogram. Is it qualitative or quantitative?
Quantitative.
A histogram has to be quantitative because it's continuous data. It has to be numerical. Okay, how many students were in the sample? So it was hours spent playing video games. This is our hours. This is the number of students. And so then we'd add each of these up, because between 0 and 5, there was 2 of them. 5 to 10, there was 3. So we'd take 2 plus 3. The next one was 4, a 7, and a 9. Adding them up gives us 25. Any questions on that? Okay, how about the mode? What's the mode? It's a little different with a histogram, because we don't know what this data is. We don't know between 20 and 25 how many there were of each. We know that in this range there was the most, but these could be all spread out. We could actually have 16, maybe there's 7 16s in here. It could have been the mode. So when you're working with a histogram and you don't have any other data with it, the mode is a range of values. And so the highest bar in our histogram is 20 to 25. So that's our mode. This
That's what I
range,
did.
yeah, this range of values had the most. So with a histogram, when you find the mode, it's a range of values. Now, how about this one? How many students spent 25 hours playing video games? No, most of the time, like if I said how many students spent 12 hours playing video games, 12 is in here, but we don't know how many. We know at most there was 4.
Would we
But
say at least 9?
well, if we said something in between here, but remember, this number goes to the next one. So if there was any 25s, there would be another bar. So like this bar here, this is 15 up to, but not including 20. When it hits 20, it goes to the next bar. So 25 would be the next bar. And since there is no bar after it, there was none. So if I give you a value in between, you can't tell me because there's a range of values. But if I give you one that's on the end, you know that there's none because there'd be another bar.
Well, would 25 be the max of that and then the least of the next? Or is 25 not? Why is it there if it's not a measurement?
Because you're going up to, but not including 25. So you could have 24 and a half hours, 24 hours and 50 minutes. So since it's continuous, it's going up to, but once you hit 25, it will go to the next one. If we were talking whole numbers, then yeah, we'd just put a 24 there. But a histogram is continuous data. So it goes up to, but not including 25. 24 hours and 59 minutes and 59 seconds. But any questions on that? So if you remember when we were counting the ages, we went up to but didn't include that year, and that age went into the next one. Any questions on that? If this one is a pie chart, would the data be qualitative or quantitative?
Qualitative.
Qualitative.
Yep. Because it's words, it's not numbers. Cell phone, drunk driving, other, excessive speed. So this is 200 traffic accidents and what caused them. So what would the mode be?
Cell phone distractions.
Mm-hmm. Cell phones and distractions. And because it's the largest percentage.
43% is crazy.
I know. No, I think this was before all the 2008, so might have been before all the cell phone laws, or probably what caused those laws. How many were caused by drunk driving? The number, not the percent.
Okay, so 12% of 200.
Exactly. So drunk driving was 12%. We were told how many there were. There were 200 accidents. So it'd be 12% of 200.
That's like 22-ish?
24.
24. Oh, okay.
Not far though. So 24 of the accidents were from drunk driving. Any questions on the pie chart? Okay. The stem and leaf, it says baseball throwing distances in feet. Now it doesn't give us any decimals, so these are the ones position. If it tells you more than that, then they could be. Trying to make it clearer. There we go. So if we were to read this, this would be 20, 23, 25, 31, 32. Notice here at the nines, there's none there. So there were none in the 90s. Okay, what's the mean? How do we find the mean?
You add up all the numbers and then you divide them by
Mm-hmm.
yeah.
Yep, so we add all of them up and divide by how many there are.
Yeah.
So we'd take 20 plus 23 plus 25 plus 31 plus 32 and add all of them up. Did anyone get an answer?
I added them up and I got 1,234.
Mm-hmm. And I think there's 23 of them.
Yeah.
And so we get 53.65217. I went one decimal place. Rule of thumb, you should go one decimal place more than your data. But since I didn't state, 54 would work. But I used 53.7. Okay, what does median mean?
I think it's like the middle.
Mhm. It's the middle piece of data. Since we have 23, then we do have a middle. So if we count, what you can do is take, where's my calculator? 23 divided by 2. So if we go 11, the next one is the middle. So just count 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it's this 3 here. And if you count, there's 11 on both sides of that 3. So our answer is 53. Now you could also put the data all in order and then take the middle one if it's easier. But I just counted 11 because there's 23. So 11 and 11 is 22, and the middle one makes 23. So our answer is 53. Any questions on that? Yeah, whenever you get kicked out, just come right back in. And if you ever have to go somewhere, just go ahead and go. I mean, you can send me a little text, but you can always look at the video after. Mode is most often. Do any of these repeat? I don't think so.
I don't have to see any. I was
Yeah.
gonna ask about
Notice that none of these repeat, so there's no mode. They need to repeat to have a mode. So if there was one more 5 here, then it would have been 25 because there were 2 25s. But since none of them repeated, there's none. Any questions on that? How many threw in the hundreds? Anyone? Two. Yeah, someone
People.
typed.
Yeah, people.
Because there'd be 102 and 105. And nobody threw in the 90s. Any questions on that? Okay. Write a few sentences explaining what the graph's showing you. A few means 3 or more. Well, the graph is a timeline because it's going over time, the number of days. And this is, if you're studying, the facts that you get correct for the number of days that you study. Notice in the first day, we remembered 3 things. By the second day, we remembered 4. Now, it doesn't mean that it was 1 more. Like if you think of flashcards, you could have remembered 3 of them. Here, you could have remembered 4, but it didn't have to be the same flashcards. It could
Yeah,
have been,
so
you
it
could have
doesn't
forgot something.
it doesn't show the like percent of facts you got right that day, just how many.
Exactly.
Okay.
But we do know from day 2 to day 3 was the biggest increase in memory. That's a big jump here. So that's one thing. One you could say is it's a timeline showing how facts are memorized. It's also kind of a learning curve over time, how you learn and you remember more the second and third day. That's why they say you don't study the night before, you study a couple nights before, because this 2 to 3 day, you have a bigger memory here. And then this one still grew by what, 3 facts. So each day, the amount you memorized always increased. The biggest increase was from day 2 to day 3. In the end, you remembered 15 facts. So you want to write, and this is kind of how your exam will be. There'll be a lot of them where I give you all these different graphs and you have to explain. The number of facts remembered never decreased. Any questions on it?
If it says the number of facts, if it's the number of facts remembered, then, oh yeah, I guess you still don't have a total amount of facts.
Yeah, we don't know that there's how many facts there are. There
Yeah.
could have been 50 of them. Hopefully not. Hopefully there's only 15, but we don't know the total number of facts. Any questions? So you have to have 3 or more sentences. Okay. What did I do with the other? Oh, there it is. It was just stuck. This is a frequency table. And it says use the qualitative data to draw a bar graph and a pie chart. Your favorite ride in an amusement park. And then how many people, what their favorite ride was. Well, before we can find percents, we need to know the total people. And so we need to add this up.
I got 170.
Hmm.
Oh, 200.
I don't know.
Yes, I got 200.
Okay. I thought I tried to make it so that it was easy to divide by. Yeah, you probably just missed one of them.
Yeah, I did. I did. I was wondering why my pie was looking weird.
Yep. Oh yeah, it would be different because you're using 200 pieces of data. The other thing you could have checked, your percent shouldn't add up right. Percent should be almost exactly 100. A little larger or a little smaller if you rounded.
Well, yeah, I rounded with 4 and got I rounded with 4 and got 100 because I did roller coaster, Ferris wheel. I did all the way down to log water ride, actually.
Oh, so you just skipped the one completely. Okay, so when you're finding your percents, remember it's the part divided by the whole times 100. So 60 divided by 200 times 100, which is 30. So we had to go 25 divided by 200 times 100, which gives us 12.5. Now, if you want to round to 13, that's fine. 50 divided by 200 times 100 is 25. 35 divided by 200 times 100 is 17.5. The reason, I'll show you why I didn't round. 30 divided by 200 times 100. 15. Okay, so on this one, I didn't round. If you don't round, it has to add up to 100 or you did something wrong. And if you add these, we get 100. Any questions on getting these values? Okay. If we were to round, I want to show you how it would be off. And that's what I mean. It's fine if you round and it's off. It should still be close to 100, somewhere between 99 and 101. If we rounded this, we have this 30. Now this one's going to round up because of the 5. But what happens is this other one also rounds up. So they both rounded up, which makes it off. And so you have that 1% leeway either way, somewhere between 99 and 101. But rule of thumb, you should go 1 decimal place anyway. So in this case, it shouldn't have affected it. But you could have used these values. Any questions on that? So these are our percents. They ask us to graph a bar graph and a pie chart. The bar graph uses the frequency, the pie chart uses percents. So our bar graph, you should always put a title on your graph. This is really making me miss the amusement park over the summer. I had forgot about it till now. Okay,
Makes
go
Cedar.
ahead.
I'm sorry, I was just gonna say it makes me want to go to Cedar Point.
Yeah. Okay, so I'm going to go up to 60 and I'm going to, I think I'll count by, probably, I think I can go by tens. Oops. People or riders. Oops. And then across the bottom would be the data, which was rides. So the first one was roller coaster. And if you look at your frequency, the roller coaster went up to 60. That's my favorite. Ferris wheel was 25. Remember, our bar graph does not touch. Bumper cars were 50. Log ride was 35. And tilt-a-whirl. Yeah. Now, sometimes what they do on these, and you'll see when we do bar graphs, sometimes they put the numbers up here. It doesn't have to be here, but when there's larger values, sometimes it's hard to go across and see exactly where it's hitting. And so they would put those. But you wouldn't have to have them. I think it makes it easier when you're looking at someone's bar graph. You can see exactly what they went up to. I think it's a nice thing to have, but it doesn't have to. But if you think about the bar graphs we were doing, if we would have had that, it would have been easier to add the total. We had to go across and make sure we were following them. So it just makes it a little easier. Any questions on the bar graph?
Way to do a bar graph and what else? Pie chart.
Pie chart. So for a pie chart, the pie chart uses the percents and it's a circle. And let's see, favorite rides. $200. And 200 people surveyed. You need to have that number. That way, if someone, when they're reading it, if they don't have all your other data, they need to know how many, so then they can find these values. Okay, oh, the percents. Bring this over here so you can see the percents. So the first one was 30%, and that was the roller coaster. Now remember, this would be a quarter. And a little bit more than that then would be 30%. Now I drew the quarter because there was one that was a quarter. That was the bumper cars. And a little more than that is my 30%, which was the roller coaster. The other three are pretty close, 12, 17, and 15. So this one looks maybe the largest, so I'll put the 17.5 here, which is the log ride. 15 here, which was tilt-a-whirl, and the 12.5. So it doesn't have to be exact, but you don't want your 30% to be the size of your 12%. Any questions on those?
Yeah, do we have to write that inside the circle, or can we just put arrows?
You can do arrows, like when we do it on Excel, some of them will write it in there, but others will make it just a different color and then they put it on the side. Any questions on that? I think that's the only two we had to do on that one. Any questions? Is everyone, I can move on? Okay. This one says, use the data below to graph a stem and leaf, a box plot, and also given the standard deviation, make a bell-shaped curve. So this one needs 3. And I recommend, well, it even says to do it on a separate sheet of paper, all of these, but. Okay, so the first one is the stem and leaf. When you're doing the stem and leaf, you want to find your leaf first. It's the rightmost piece of data. Well, looking at this data, the rightmost is the ones position. And it looks like we go to the tens, but we don't go to the hundreds. So notice this one is just a ones. So that means the 10 position was a 0. So we need to go from 0, and the largest, I think, is a 50. Yeah. So our stem and our leaf, the stem would be the tens position. The leaf is the ones. So we go from 0 to 5. Now we don't worry and make sure that there's ones in all of these, because if you remember the one we looked at here, if there is one with none, you still show it. This meant there was no 90s. So once you start, you keep going till you're at your last one, even if there's one with none in it. So if we look at our data, the tens position, there's only one, it's a 9. This one right here. So from 0 up through 9, there's only one. Then you look at the tens. For the tens, there's 2 of them. There's a 17 and an 18. So it'd be 7 and then 8. Then we look at the 20s. For the 20s, there's a lot of them. These need to go in numerical order, so you have to find the smallest 20s first. What I did when I did it the first time, if I have my paper. There it is. I found all of them first, and then I went and put them in order. So sometimes that helps. But since I already did it, I know where they all are. So there was a 20. There's only one of them right here. And then there was 2 23s. Somewhere. And then there was 124. And I think it goes in order: a 25, a 26, 27, 28, and 29. 4, 5, 6, 7, 8, and a 9. Then go to the 30s. There was 2 34s. Here's 1, 2. And then there's 2 35s. 1, 2. And you want to kind of keep these in columns so they stay equally spread. So then if we turn it, it kind of looks like a bar. 2 5s. There's a 37. And then there's 4 of the 38s. 1, 2, 3, 4. And I think 3 39s. 1, 2, 3. Any questions on that? And then we go to the 40s. There's a 42. Two 43s. 1, 2. 2 44s. 3 45s. 3 46s. 48 and a 49. And there's 3 50s. Any questions on that? So there's no easy way. I mean, you could put them all in groups first and then order them, but they do need to be in order. Any questions on that? Okay. To find the box plot, you first need to find the 5-number summary. That's the smallest number. The lower quartile, the median, the upper quartile, and the largest value. Okay. Well, smallest and largest is easy. The smallest is 9, and the largest is 50. Now, the median is the middle number, and there are, I forget how many pieces of data. 5 times 1, 2, 3, 4, 5, 6, 7, 8. So there's 40. Which means the middle, there's an even number of them. So it'll be between the 20 and the 21st. Because if you take half of 40, you get 20. So there's 20 on each side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So this is the 20th and the 21st. Because it's even, the median is going to be right between them. These are 38. So it's 38 plus 38 divided by 2, which is 38. Now, if it's confusing doing it with the stem and leaf, you could write all of them in order and then find the middle. Any
How did
questions?
you get the 40 pieces again?
Count how many there were. I used this because they're in groups of 5. I counted by 5. 5, 10, 15, 20, 25, 30, 35, 40. So you're just counting how many there are.
Okay.
Since there was 40, to split it in half, it would be 20 and 20. So the middle is between these two, which when they're the same value, it would be the same value. I think the lower quartile is on the same type, but then this one's different. So we look at the lower quartile, you start from where my pink line is, everything below it, you find the middle. Well, if we cut this in half, that means 20 on each side. So we're splitting the 20 in half, which would mean 10 and 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's going to be between here.
So the lower quartile is the median of the lower half, and then the upper quartile the opposite.
Exactly.
Okay.
So you take the lower parts of the value, so that would eliminate these, and you find the median. And that's lower. And then for the other one, you get rid of all the ones above, and you just use the bottom half. So it's just medians of your lower and your upper half. So this one would be 27 and 28, which is 27.5. Okay, go ahead and find the upper quartile. You do the same thing as we just did for this one, only you do it with the upper part. It's still 20% of the data. So we'll count 10 from here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is the 10 and the 11. So it's going to be in between here. Which is the 45s. So it's 45 plus 45 over 2, which is still 45. Any questions on that? Okay. So you want to draw a number line. I'm gonna count by fives. Now, once you have your number line, you put a vertical line above each one of these numbers. So 9 would be about here, 27.5, 38, 45, and 50. So each one of these numbers gets a vertical line above it. The inside 3 get a box, and then the whiskers goes out. And that's why sometimes instead of a box plot, they call it box and whiskers. Any questions on that?
Why'd you put that box over that again?
Say that again.
Box there.
It's just your upper quartile and your lower quartiles, and then the medians in the middle.
Right.
Okay.
Each of these values. So I put a line up for each of them, and then the middle gets a box, and then the outside 2 get a whisker. This one's stretching a lot more than the rest, so it's probably an outlier. But any questions on that? The other one it asked us for is the bell-shaped curve or a normal curve. They told us the standard deviation was 11, but they didn't give us the mean. So we need to find the mean. Which means,
Were those symbols standard deviation and mean?
yeah, this one's mean. It's an X with a line over it. Oops. And this one means standard deviation. They also use an S for standard deviation, but my S's look like 5s. So I use this. The standard deviation is what we'll count by. The mean is your average. So that means we need to add up all of the data and divide by how many there are. So you need to add all of these up and divide by how many there are, which is, we know there's 40. So you need to add all of them up and then divide by how many there are. Did anyone add them up? In my other class, we got 1449 when we added them. Is that what we're getting? And then we divide by 40. So it's approximately 36. Any questions on that? We'll definitely have to graph these on a test.
I forget what standard deviation is.
Standard deviation is what we're going to count by. I did not show you how to find it because what you'd have to do is take every one of these pieces of data, subtract the mean, square that value, add all of them up, and take the square root.
So did it just give us our standard deviation?
Yes.
Oh, okay.
Yeah, it was given. I will give you the standard deviation.
So it's just like 11, 22, and then next 11, next 11.
Yeah. But well, you start with 36 in the middle. Let me make it a little bigger. So you put your mean in the middle, which was 36. Then you're going to go 3 units each way. 1, 2, 3, and 1, 2, 3. So the mean is in the middle, and then we count by that standard deviation, which was 11. So 36 plus 11 is 47. Plus another 11 is 58, and one more is 69. So going this way, we add by your standard deviation, which is 11. Going the other way, you subtract. 25, 14, and 3. Any questions on that part? So I drew 1 in the middle, and that was my mean, and then I counted by my standard deviation. This way you add the 11, and this way you subtract it. Now the percents inside, you need to be careful because your book is different than other books. So there's a few different variations online. Yours uses 0.1, 2.1, 13.6, and 34.1. If you look online, there's another one up there, which my stats class uses.
Is that no, that can't be that. What is that?
Those are the percents between the curve. So between 25 and 36, there's 34.1% of the data. Between 58 and 69, 2.1% of the data. So the majority of your data is in here, and then it slowly goes off.
How did we get that?
Those are given. So you have to memorize those. Or since it's open notes, you could have that written.
Wait, okay. Jeez, I'm confused.
So we could literally use this for our test, because this is like a good example, I guess, right here, right now.
Yep. There's also one of these on the QR on the
Oh, okay, I just got it.
Yeah. So this part here, it will always be the same.
If it's always 11 or no, I can't be right.
No, standard deviation will be different. But these percents are always the same. And then the mean and the standard deviation will either be given or you'll have to find. You won't have to find standard deviation, but you'll have to find the mean.
So it just helps me to know, like, how do we know those will always be the same? Like, why?
Because it's a normal curve. If you get enough data, everything falls into a normal curve. If I take one class, maybe it won't be in this percentage, but if I take 10 of my classes, then my grades are going to fall into this. This might be my high C's and my low B's, and then the higher B's, and then the A's, and then the perfect grades. It falls into that, and then the F's are really small. So most curves, once you have enough data, will fall into a normal bell-shaped curve.
Oh, so it's like a recurring pattern that we're memorizing.
Exactly. So they've done enough studies, and then they say 30 pieces of data should get you a normal curve, but I think you need more than that. But
Got you.
done enough studies, so that percent will always be the same, and then you'll be given a mean and a standard deviation to fill in the bottom line.
So that's why small classes never have a bell-shaped curve to their grade.
Correct. I had one class that had 100, so that helped get your bell-shaped curve. But
That's
okay.
kind of cool to know, though. I never knew that.
Any questions on that? When we get this homework, I think that was everything for that one. Yeah. When we get this one done, we could go over the correct just to make sure you understand this, because it's the same problem. Different numbers, but the same. Any questions on that one?
Wasn't there a 9th question on the
Yeah, there's
homework?
one more.
Okay.
And I think I can just graph this on here. For the information on tornadoes, draw a line graph. Notice that this is time. Line graphs are almost always time. So what we do is or we could just call it tornado. You should also always have a title. This would be the number of tornadoes. And this would be the year. And we're going from 0 to 36. So I'll probably count by 5s. 5, 15, 25, 35. Okay. So I went by 5s. You could have went by a different value. Starts in 2003. Okay. Any questions so far? So we put the years on the bottom. Frequency always goes up. In this case, it's the number of tornadoes. So in 2003, there were 13. So you make a point at 13, right about there. In 2004, there was 8, right about here. In 2005, there was 4. 2006, there was 36. Right there. 2007, there was 12 here, and then 13. So you mark your points so that they go across for how many there are. Kind of like when we did the bar graph, only you don't have the bar, you just have a dot. Because then it's called a line graph. We're going to connect them. This is similar to the one we did with the amount of things you memorized. So then you just connect your lines. I don't know where this was from, if it's one specific area or if it was Ohio. But you can tell there's usually somewhere between 5 to 13 tornadoes each year. This one year there was a huge jump in them. So by having the line graph, you can see where that spike was. Is there any questions on it? Any questions? I thought I had we can look it up though. But is there any questions on that one? Okay, let's see. I'm gonna bring up the co-rec homework.
I'm gonna go use the restroom real quick.
Okay, where's my Google? There we go. Oh. Oh, that's right. I had to close it. It's thinking. There we go. Okay. So why issue? Okay. So in here, week 7. Quiz. There's a quiz. There's a mean, median, mode, and range you have to find. And I forget. Oh, you know what? I think you have to do qualitative or quantitative, discrete or continuous, stating what it is. But then the co-rec homework is a normal curve. And it's not, it wasn't showing you, so I'll bring it back up. Nope. There it is. Okay. So it's saying draw a normal curve. The average speed, average would mean mean, is 6.3 with a standard deviation of 0.5. So you want to draw your normal curve and use the percents I gave you from the previous problem. Your mean goes in the middle, and then go 3 units each way. Go ahead and try it. I'm going to write the questions down, so then I'll go to my paper after. What's in terms?
So the deviation is how much we count up and down by?
Yes. So
Okay.
in this case, you'll be counting by 0.5. Mhm. Okay, I'm going to flip to my paper now.
So we on the right side we add by 0.5, and then on the left side we subtract by 0.5.
Exactly.
Okay.
Was the average speed 6.3?
Yes.
So that would be the median?
Yep.
Okay.
Average and median mean the same, so 6.3 goes in the middle, and then go 3 units each way. And then we count by the 0.5s. So do your values go from 4.8 to 7.8?
Yes.
Now the percents will be the same. Over here's 0.1, 2.1, 13.6, 34.1, 13. Okay, so any questions on the curve?
I actually know how to write it now because of this. Like,
Okay.
I was just confused up until now about like what all of this was. So
Yeah, I
I'm
figured if
good
we
now.
did, good. I thought doing this one together would help. No, in this one it says, what percent swim less than 7.3 miles per hour? So we'd want to find the 7.3, which is here, and we want everything less than it. So when you're given these questions, if these values are not here, then you probably did something wrong. But we want to go from here over. So it would be all of these. 0.1 plus 2.1 plus 13.6 plus 34.1, another 34.1. Whoops, this is a 6. And we're stopping at the 73, which is right here. So I took all the percents below it. And you want to add those up.
And we would divide it by 5, right?
No, we just add them all up because each
Huh.
one's the percent.
Oh, yeah, that makes it easier.
Yep. Are we getting 97.6?
I got 97.5.
1, 2, 3, 4. You should get 6. You might have missed the 0.1 maybe.
Oh, maybe.
15, 16, yeah. So 97.6% of turtles swim less than 7.3 miles per hour. What percent swim more than 58? 5.8, sorry.
A 3.4.
More than 5.8. So 5.8 is here.
Oh wait. Oh, I was doing the rest of the missing. My bad.
Oh, okay. Yeah, more than 5.8 then would be everything from 5.8 over, which is this one. And that way. So it would be the 34.1 plus the 34.1, 13.6, 2.1, and 0.1. Getting 84.
Yeah.
So aren't all of these answers approximate since our percentages are based on a whole average, not the actual percent?
Yeah, these are all approximate.
Okay.
Let's try one more just to make sure you understand it. What percent of turtles swim between 5.8 and 6.8 miles per hour? So what percent of turtles swim between 5.8 and 6.8 miles per hour?
It should just be 68.2, right?
Exactly.
Just because we're only using those two.
Yep. So we're going between here and here. Oh, let's choose the pink. Going between here and here for this one because it's going from 58 to 68. So we want all the values in here, which would be
So could you just find the percent of 1, 2, 3, 4, 5, 6, 7, the 2/8? So 4/10, 40%.
I'm not sure how you're getting. You just
The
want to add your percents under your curve.
Yeah, I'm just confused with the gaps, I guess. So the 0.1, 2.1, 13.1, not those actual numbers, but the gaps. There's 1, 2, 3, 4, 5, 6, 7,
Oh,
8
okay.
gaps.
Yeah, no, you can't because it doesn't break equally.
Okay.
Yeah. And also your curve, if you add up all your percents, it adds up to 98.8. This normal curve leaves room for outliers, the other 0.2%. The reason other curves are different, they add up to 1. So I'm not crazy about this one. I like when they add up to 1 because then you have all of them. This is leaving room for outliers.
Yeah.
Actually, I think it's 99.8. I don't know why. Yeah. 6, 7, 8, 9. Yeah. And so it's not including all of the data in here. But is there any questions on reading it? Do you need to do one more? Do you want to try one more normal curve, or are we good?
I think I'm good on it personally now.
Okay. I think doing this extra one helps. Okay. So remember, you still need to turn this in. This was the co-rec. Is everyone okay reading it? What percent of turtles swim faster than 7.8?
Point one.
Mm-hmm. At 7.8, it is just here because we said more than. So it's just 0.1, a tenth of a percent.
That's so weird. Like I know how it works and stuff, but sometimes I catch myself like 0.1, 0, 10%, but that's not correct because it's already moved.
Right, right. That's a percent. It's not
Yeah.
a decimal. So it's very small. Yeah. Okay. Well, if you do not have any questions, I will see you on Friday. Friday, we will work on using Excel. So we will not have a group assignment.
Thank you.
You're welcome. Have a nice
Excel
day.
Excel comes free with YSU, correct?
Correct. Yep.
Okay.
Okay. Have a nice day.